Okay, looks like a pretty difficult integration. And what I would do over here, since I'm looking at the integrand, and the integrand, defined for all t, and certainly defined between minus pi over 4 and pi over 4, I'm going to split it into two integrations. And the first integration looks really simple to do. It's minus pi over 4 to pi over 4 cosine of t dt plus minus pi over 4, that's the root of 1 plus t squared times sine cubed t cosine cubed t dt. Well, let's do the first integration. Looks relatively simple. All right, what's it going to be? It's going to be sine, because derivative of sine is cosine, of t, evaluated from minus pi over 4 to pi over 4. We'll look at the second one, though. I'm going to look at the integration. And what I immediately notice about this thing, it's symmetric limits about the origin. So it would be great if this function here, this integrand, were odd. Let's write this down. So f of t, I'm hoping it's going to be odd, is equal to the square root 1 plus t squared times sine cubed t times cosine cubed t. Again, I'm hoping for odd. What does that mean? I'm hoping that f of t is the same thing as minus f of minus t. Well, let's take a look, and let's write that down. Let's write down f of minus t first. Well, plugging it in, you'd get this, t squared. That's not a problem. And let's see, the sine of minus t is minus sine. So it's going to be minus the sine cubed of t, just using the even-odd identities, by the way. And the cosine's an even function, so it's just going to be cosine cubed of t. Then I'm going to do this, the opposite of f of minus t. And what does that equal? The root of 1 plus t squared. And I'm taking the opposite now, so it's going to be sine cubed t times cosine cubed t. So now I know it's odd. Now, certainly just to remind you, I don't know exactly what it looks like, but if it's odd between pi over 4 and minus pi over 4, whatever the image is here is going to be over there, and the areas will be identical but opposite. So this thing's going to integrate to 0. So I just have to evaluate this. When you get over here, sine of pi over 4 minus the sine of minus pi over 4. And we need to evaluate that. And that's going to be 1 over root of 2 minus, that's going to be minus 1 over root 2. So what do you get there? You would get 2 over root 2. I'm going to rationalize that by multiplying top and bottom by root 2. And what do you get there? You get 2 root 2 over 2, or just simply the root of 2. All right? So the answer there, looking at the k, would be answer, choice B. All right, I want to emphasize that these come from standardized exams, and you really should practice a standardized exam. It's typically the most typical way students are assessed as to their ability. All right? So you might say, how much time am I given to do a problem like this in a standardized exam? I'm typically, say about, they give you about, I'm going to say between 2 and 3 minutes. Now, by the way, some questions you can answer in a few seconds. Other ones are going to take more than 3 minutes to do. But it's good to be able to, quickly go through it. You don't have to be neat about it, but quickly go through the problem and write an answer down quickly. Now, someone says 2 to 3 minutes per question. How many questions would you have? I'm going to say roughly there would be 70 questions. I know that seems difficult. It's a goal you want to get to, though. You want to be able to take a multiple choice exam where you're taking a large number of questions, answering them rapidly. All right? Thank you.